Hey guys, hope you guys are doing well and enjoying the class so far. We're going to talk briefly about some introductory statistics that ecologists sometimes use, just sort of getting an idea of what data looks like that you may have collected. And this relates to your assignment for collecting 50 to 100 measurements. So to start with, I have these few quick slides we're going to go through, and the first thing I want to say or talk about is that we use statistics because we can never measure an entire population that we're interested in. And so you can think about this really as sort of the idea that we want to know what the average height of a person is. Well, we clearly can't go out and measure the entire world's population or even the entire population of our, say, community that we live in. So instead, we take a sample, and the sample of that community is a small subset, and you can sort of see that here, sort of a small subset of the population that we're interested in. And we need to understand the mean, how much variance is associated with that mean, and some other key characteristics. So a few summary statistics that we're going to talk about are the max and min, the mean, and the mean is the average number of a series of numbers, the mode, which is the most commonly observed number in a series of numbers, and the median. And I will say that the mean, mode, and median are considered measures of central tendency. And the median, I don't think I said, is the most central number in an ordered series of numbers. And then last, we're going to talk about standard deviation, and this is a measure of how spread out the data is. And technically, it's the square root of the variance, and the variance is simply the average of the squared differences from the mean. I'm not really worried about you understanding all the technicalities here. We're going to do this in Excel, and I'm also going to show you this in Program R. We also are going to talk briefly about visualizing data, and so we can use, and we're going to focus on histograms for right now, but you can also use things called box plots. And in this histogram, you can see the distribution of the data. It ranges from up around 35 down around 6, and then here I've added the mean, which is right at 21. So now let's go ahead and jump into the Excel work. So I will say that the data here that I generated is randomly generated. I didn't go out and measure 50 things, but each of these numbers represents a random number with a mean of 21 and a standard deviation of 2.5. And these random numbers were generated with this equation, which is a normal distribution with a random number generated with a mean of 21 and a standard deviation of 2.5. I then copied and pasted those values as I pasted them as values so they didn't constantly change. And I then copied that and saved it as a CSV file to pull into Program R, which I'm going to show you in a minute. So I want to talk about minimum, the way that you can generate these things. And you could do it by hand, obviously, but that would sort of defeat the purpose of using our spreadsheet in a statistical software package such as R. So minimum is pretty simple. You can see here that the value is, you have to always put equals. I'm going to avoid that right now, but it is min of the number, well, I'll show you. So it is equals min, and you need to select all of the data, and you can see that it goes down to row number 51, and so there's our mean. And then we can also do max the same way. So in max, you would say equal max, and then the column we're in is A, and the data starts in 2, and it goes to A51. And the same thing, you can see that is 25, it says. Why is that? Oh, we changed here. Hang on a second. Somehow that's correct. Oh, I think I know why. A2 to 51 says 27. A2 to 51, it says, I believe I know why. Actually, I don't know why. but this is a good reason to use program R. So anyway, the equations, I'm just going to type the equations would be equals min of A1, A2, sorry, to A51. And then the same thing for max and mean, mode, median, and standard deviation. Except I will say that standard deviation, this should be, instead of, it is STDEV is the function. So with that, and you can sort of see here our different standard deviation, the mean, the median, and you'll notice that, for example, the standard deviation, while we designated as 2.5 as the standard deviation, because these numbers were randomly generated, it didn't come up with an exact value of 2.5. It came pretty close, 2.39. So now I'm going to switch over to Program R, and Program R is a free statistical software package. It's open source. Intimidating if you're not familiar with these types of software packages, but you can't really mess it up, so you can download it for free. And this is actually RStudio, so you can see the little RStudio up here. If you're interested in using R, then there are certainly tutorial videos online that you can look at. I would also recommend R for data visualization by Hadley Wickham, and it's a really good book if you're really interested in getting into the use of R. So the first thing we want to talk about is that these are some simple statistics that ecologists would sometimes use in the early stages of looking at the data. Now you'll notice that I have put a pound sign, or a hashtag, if you will, before lines where I don't want R to try to do some function on the data. So I'm not telling it to do something here. This is just sort of annotating my work. So the first thing that I did is set the working directory, and so you can see this work is in my D drive, in my Google Drive, and I have this folder set up in my Google Drive. You can see the file pathway there. Another way that you can do this is simply go to Session and scroll down to Set Working Directory, and you want to set working directory to the source file location. If your data, or you don't want to work in your source file, then you can choose the directory. But it's easier probably to keep your files all in one place. So select source file directory. You can see that it did some work down here. Let me clear this as well. And then the data set that is exactly like the Excel work. I just renamed it as just a CSV file, an R file without the other. I'll open it up real quick so you can see. It doesn't have the other information that the file had when I was working in R. So I had to give it a row ID and then a name for the column that we're going to be working in. So we look back again. You can see that I have these different codes for the simple statistics that we're going to do. Oh, I'm sorry, I should first say that we're going to pull this data in from the directory, and I just named it 50. It is a CSV, so I type read.csv, and in parentheses I put the title of the file, the name of the file, and then it does have a header, and it is separated by a semicolon because it's a CSV. I'm sorry, a comma because it's a CSV. It's kind of separated. And so then the different statistics that we are going to run, and you can see, let me go ahead and pull in the data set, and you can see down here that 50 has been entered. We're going to say, I'm going to show you what it looks like if I just type 50 to show you that the data set is called 50. And you can see there it is. I can scroll back up. There's our row ID and our column name 50. And then our simple statistics, and I just simply named these different things so I can recall on f.min. So I can say Control Enter, or you can hit Run. And so you can now, if I want to recall f.min, so that's the minimum for 50, you can see that it is 16. And you can work down in the console down here. Let's see what else. We have range. Oops. Range, and you can see that the range is between 16 and 27. Of course, that is the upper and minimum values. The mean is 20.84. The median, 21. standard deviation, and histogram. Now, one of the great things about using R is that there is a ton of information on the internet, and this is largely because it is an open source software. And so if you ever have a question about how to do something, you can just type it into Google, hit go, and you'll find a whole bunch of information on how people have come up with a solution. And so then, I typed all of these different equations in, these different codes, and I should maybe break that down. But so this is the name, f.min is the name for the minimum. So f is 50.minimum. And then the min is the code for minimum. And I had to call the data set 50, and then I needed to tell it that in the data set 50 that I wanted the column 50. So I used the money symbol there to designate that. So I did that with all of these different things. Now, you can also simply do summary 50, and you can see down here that there's a summary. So it does have the median and the mean. There's not the mode, there's not the standard deviation, but those things are pretty easy to generate also. But it is a quick and easy way to do that. Another quick thing I want to show you is if you are interested in just the names of a data set, you can say names and then what data set you're working in. It'll give you the names. If you want the head, so just the top 5 rows, you can say head 50. It'll give you the top 5 rows, or it looks like top 6, sorry, the top 6 rows. And then you can also say tail of 50, and it'll give you the bottom. There are other functions that you can use with your data set as well. But so what I wanted to do now is to talk about visualizing data. Visual data with histograms. So how does the data look if we increase the number of observations? So I should have said, here's our histogram function, and that's just hist. And you'll see over here, and I'll zoom in on that, but you can see the distribution of our data here. And so you can see that the mean is probably right in this area. The distribution ranges from about 16 to about 28. So what if we increase our number of observations from 50 to 1,000? So this is a random number generator also, and this is the number of observations we want is 1,000. We still have a mean of 21 and a standard deviation of 2.5. So if I hit that, then I just called that 1,000 2.5. Then I want to, let's take a look at the histograms to visualize the difference. So this is simply a function that R uses to set up the number of rows in a plot. So it's a 1:2 plot. And so histogram 1,000, histogram with an AB line, and the AB line is simply the vertical line for the mean of 1,000's 2.5, 1,000 2.5 with a color of red, a line weight of 3, and a line type of 2, and the line type is just the dashed line. And then we go to histogram again of 50 with the AB line, and you can see that when we start to compare these two, we have 1,000 values. You can see that we get a much more normal distribution, right? Here we have a less normal distribution. It's still somewhat normal, but our means are still somewhat the same. So, but while talking about it, let's see what the mean of 1,000. 2.5 is. See, the mean is pretty near 21. So what if we add 2 more data sets and we change now, instead of changing the number of observations, we stick with 1,000 observations, but we change the standard deviation to 5 and to 15. So let's see what these look like. Again, setting up the number of columns and rows, and there's one row, 3 columns. And zoom in on that, and you can see that there are, if we have a 2.5, a 5, and a 15 for our standard deviations, you can see that we have a greater spread when you go from 2.5 to 5, and then even greater when you get to 15. So for example, our mean is still right at 21 for all of these, but now you can see that our our range is 15, in the graph anyway, is 15 to 30 for 2.5, the standard deviation 2.5. For standard deviation 5, we have from 5 to 40. And then with a standard deviation of 15, we get into the negative 20s and up above 60. So, again, I don't mind you working in R or Excel for this work. R can be something that students, I think, will struggle with in your class, but they can also gain quite a lot from it. And it is sort of a standard software package that folks use in ecology now, particularly since it is open source and there's a ton of information that is available online. And it's can be a good time for students to sort of struggle with it and understand how to use it. So I'd encourage you to take a look and see if you can figure out how to do this in R if possible. See you later.